the previous class, when we were doing this magnetic flux and Faraday's law, so then we did a question. Yeah, this was the question. In this question, I made a mistake, right? So when we calculate, right, when we calculate the charge, so we don't write it, first we don't calculate this I and then we calculate this dt, right? Then it can, yeah, so then it can be, so our calculation can be wrong in that. We have to directly calculate, yeah, so when I was thinking about this question later, so I made a mistake in this question, right? So let us correct that part and then we will just correct that part. Yeah, so we had this, right? And we have to calculate the charge in this. Then calculate the charge, we have to always remember, right? We have to use a different formula for that. What did we do? What did we do in our case? We calculated the I first by differentiating, and then we calculated the charge. So that is the wrong way, right? We have to directly calculate the charge. When I differentiated that thing, in that moment it was wrong. We have to first fix that thing, and then can. Yeah. So what was the thing which we did? So in this question, what was given? Yeah, it was correct. So and in this question, we had to find the net charge, right? The net charge they wanted us to find. So how can we find that net charge? We know that the EMF generated is minus d5 by dt. So if this is the EMF, right? If this is the EMF, then current would be what? This is the voltage. Resistance is 10 ohm. So what would be the current? What would be the current, Tariq? Yes. What would be the current? You have voltage. You have
Yes, sir.
resistance. You have voltage. You have resistance. So what would be
Yes,
the
I
current?
is equal to V by R.
E by R. So this would be E by R, right? And
Yes, sir.
E we know already. E is d5 by dt and 1 over R of that. So I would be minus 1 by R d5 by dt. And let's say that we forget about this part, right? So this would be I. And what we did was that we calculated this I first and then calculated the charge. But that is the wrong. We have to directly write in here that this is d by dt so that our this dt and this dt will cancel out. So we can directly calculate the charge by just by just finding out the difference between, so delta Q would be simply delta phi by R. That is correct way. But we calculated this thing first and then we calculated this dq by dt, which was wrong. That was the mistake that we did in the last part. So let us now find that out. So we have to just find the change in flux. And we saw that the area is fixed, right? Only the magnetic field is changing. So delta phi would be what? A delta B by R, right? So A and delta B is how much? That is B final minus B initial divided by R. So that was the correct answer. So delta Q, that would be how much? Area we calculated. Area is 3.5 into 10 to the power minus 3. And B final, let us calculate B final at 10 milliseconds. So at 10 milliseconds, B at 10 milliseconds, that would be how much? 0.4 sine of 0.5 into 10 pi t. Right, so this is how much? This is 0.4 sine, and this is how much? So we can write this 0.5 as pi by 2, right? So 10 pi by 2 is how much? 10 pi by 2 is 0.4 sine. And how much is 10 pi by 2? So we can write this as, let's say, pi 4 pi. So 4 pi plus, yeah, pi by 2. So this would be 9 pi by 2. But this is, yeah, 10 pi by 2. So we can write this as how much? Okay, so this is 10 milliseconds, right? So this is, oh, T is, yeah, so this is 10 milliseconds. So 10 pi by 2 would be how much? 10 pi by 2 is how much? This is pi by 2, right? So that would be 1, right? This is 10 into 0.5, so that is 5 pi. Okay. So the next chart transfer is 10 pi by 2, right? T is 0.5 pi and T is 10. So this is how much? This is 5 pi, right? 5 pi, 5 by 2. 5 by 2. We have to write in the form of 5 by 2. 5 by 2 into is 10. So that would be 0.4 on, right? This is B final. And B initial would be how much? That would be 0.4 and sine of this 0. So that would be 0, right? So this B final would be simply how much? That would be simply 0.4 minus 0 divided by R is how much? R is 10. So this would be simply 10 ohm. And then we can write this thing as how much? 3.5 into 0.4 and 10 to the power minus 3 divided by 10. This would be how much? This is 70 and 2. So if we take this by 10, if we take this by 10. So this is how much? 4 fives are 20, 4 threes are 12 plus 2, 40 into 10 to the power minus 6. Right. So this would be how much? Yes. 5, yeah. cancel out 4 5s are 20, 150. And how many zeros did I put? So it's 10. R is how much? 10. 0.5. This is 10 to the power 3 that I'm getting. 5 is the problem of 0.5, 0.4. That is 4 into 10 to the power minus 5. Why am I getting this? This should be filling up, right? A and 0.4 divided by 10. So 0.04 and then 35. So that should be, this should be 0.14 into 10 to the power minus 10. So this should be this should be 0.14 millicoulomb. Right? Again, we are missing some order. Yeah, so this should be the correct answer, right? What are we missing? Here is this, right? And then 1 by half by the cos theta. A we have taken out and A is point and what is together this one. Yes. So yeah, this should be the answer, right? Again, what did we miss in this one? This is what foot is that and it is where all the things are in assignments, right? This- Okay, so this should be 0.14 million, right? Is this clear to you, Tarif? This would be the way that we would do this problem. Is this thing clear?
Yes, sir.
Yeah, then please note it down. So please correct that part. So this was the mistake that we did in the last class. Please correct that part and then we'll
Yes,
move
sir.
on. And then we'll move on to the next. What is please note down this part. Whenever you have noted it down,
Yes, sir. So you were saying?
yeah, whenever you have noted it down, please tell.
Okay, sir.
Yeah, whenever you have noted it down,
1 minute, can you scroll up? Yes, sir.
yeah, this is the
Yes, sir. Can you scroll down?
yes, noted, Tari.
Yes, sir. Done.
So then we studied about this emotional in the last class, right? In the last class, we see that this would be the emotional element, right? And we also calculated the direction of the EM, right? So that part we did, right? And then, so this was when we were moving this wire in this way, right? We were moving this wire in this way, and we can also rotate this wire. Second thing is that we have this coil, right? And this you have also seen in this AC generator. And then we rotate this coil, right? The current is passing like this, and we rotate this coil. So for this one, the EMF generated was how much? Because we knew that the flux was VA and cos omega t. Right? This was the flux. So then if we calculate the EMF generated, that is minus d phi by dt. That would be minus d by dt of VA cos omega t. These two things are fixed. So that would be simply minus d by dt of cos omega t. So the differentiation of cos omega t would be how much? That would be minus of minus sine omega t, and this omega is also there, so that would be omega again. So minus minus will cancel, and EMF generated in such coil, that would be BA omega sine omega t. So this is the other thing, right? And then the third case is that you have this magnetic field, right? You have this magnetic field, and this magnet, right? So for this one, let's say you have this Yes, Tari, sorry about that. I got disconnected. Yeah, sorry about this internet issue. Yes, are you there, Tari?
Yes, sir, no issue. It happens for me.
Yeah, okay, yeah. Host a disabled participant screen share. Talk to me. Okay, yeah. So we see that in three ways we can generate this motional here, right? So due to the motion of the coil, we can have three kinds of motion here. One is that we just take one side which is linearly moving. So that will give us BLB, right? BLB sine theta. And generally we don't have any angle, so that is BLB. And then we can also rotate the coil, so that will give us BA omega sine omega t, right? And then the last one is when we move the rod in a circular motion. So let's say that you have this cart, right? Bullock cart, and in that bullock cart, those ribs provide some magnetic field.
Not sharing.
Yeah, so I see that because I'm not the cook, so I'm not able to. Yeah. Because as you see, I'm not the co-host, so I'm unable to share my screen. Right? That is, yeah, now I'm. Yes, so as I was saying that we can have three kinds of, in three ways, we can have this motional right? So one way is that we make this arm free, right? We make this arm free and move this arm. So in this way, we will change the area. So then the motional EMF would be this, right? And the other thing is that we have this coil, we rotate this coil. So due to that, we have this motional EMF, which is PA sine omega t, right? PA omega sine. And the third one is that we have this rod and we move this rod in circular motion in the presence of this magnetic so in that way also we can generate this EMF, and this small EMF would be how much? That would be uh, B and C, and this length is a small length dx. Right? So this is the dx. And we know that in circular motion, what is the linear velocity? Linear velocity is related with the angular velocity as this. This distance is x, velocity is, let's say, v. So that would be related with the angular velocity as this thing, because we know that this relation holds. Right? V is omega r in circular motion. So similarly, v is omega x. So if we put that value and we integrate this thing, so EMF we will get would be half b omega and whatever this length of this rod is, L square. So this is the EMF of this circular motion. So these are the three kinds of EMF that we have to remember. Okay. And from this EMF, we can calculate power, we can calculate, yeah, whatever we want to calculate, we can calculate all this. So this part you have already noted. Please note down these, and then we will do a couple of questions on the basis of these. Please. Okay, so I have used this rectangular coil, kinds of coil. But remember, if coil is rotating, then this would be the EMF, motional EMF. If Yeah, so please note down this part, and whenever you have noted it down, please that. Yeah, whenever you want me to scroll down, please that. Yes, Tariq, whenever you have noted, please just.
Yes, sir.
Yeah, whenever you want me to scroll down, please that.
Second is called.
So remember, whenever you have a rod, right, and you are moving this rod, right, in circular direction in the presence of this electric, then this rod will create an EMF, and that would be equal to this. So this is very important relation, right? Yeah, whenever you have noted it down, there will be a couple of questions. Yes, noted, Tariq.
Yes, sir, noted.
Okay, so now let us do some question. First question. So this is the question. Right, a square loop of side 20 centimeter. So the square loop is this square, right? This is the square loop that we have, and its side is 20 centimeter. This is the square loop, and its side, this side is 20 centimeter, right? And this is moved and resistance 1 ohm. So this has a resistance of 1 ohm, right? With a constant velocity v naught. The right arm of the loop is in uniform magnetic field of 5T. The field is perpendicular to the plane of the loop and is going into it, right? The loop is connected to a network of resistors, each of value, whatever these things are. What should be the value of V naught so that a steady current of 2 ampere flows in the right? So first, this loop is connected at this point, and this loop is connected at this point, right? So these 4 ohms and these 4 ohms, they are series in series, and this 4 ohm and this 4 ohm, they are in series also, right? So if we make the diagram of this part, so the effective resistance of this part is how much? So that would be R effective. That would be, this is in series and this is in series. So 8 ohm and 8 ohm. So this is the effective resistance, right? And then this is connected to this magnetic field which is, so this is creating an EMF, right? This part is creating an EMF which is this thing. And what would be the EMF of this point? The EMF of this point would be VLV, right? VLV naught, right? And this has some resistance also. This has a resistance of 1, right? So we have an EMF. What is the effective diagram? We have an EMF and we have this effective resistance and this is small resistance, right? This is 1 ohm and this we are trying to figure out. And the current is how much? Current is, how much is the current? So current is 2 milliamp, right? So this current is 2 milliampere. This is whatever ohm is this. So we can calculate this voltage, right? This voltage would be how much? That would be I R effective or R total. So that would be I R total, and we have to calculate whatever this R total is, right? So R effective would be how much? R effective would be 8 into 8 divided by 8 plus 8, right? If we have two resistance, so this is the effective resistance, right? Is this thing clear? Yes, Tarif, is this thing clear? So you have an EMF, right? This part is generating this EMF, and this EMF is connected to this circuit, right? This is the circuit with which it is connected. So this EMF will create some current, and you want this current to be 2 milliampere, right? Then you have to fix this velocity. So this is what in this question you have to find out. Right, so first we have to calculate what is this effective resistance. And this thing in series, so that would be 8 ohm, this thing and this thing in series, so that would be 8 ohm again. So 8 ohm connected in parallel. So in parallel, how do we calculate the resistance? So that would be 1 by R effective, that would be 1 by 8 plus 1 by 8. So this would be, yeah, we can directly calculate this. So that would be 2 by 8. So R effective would be 8 by 2. Right? That would be, we can do we can do this in this way, or we can directly write it as 8 into 8 divided by 8 plus 8. So this is 64 divided by 60. So that will also give you 4. Whatever way we have remembered this. So the R effective is now 8, right? This is the R effective. And then you have to calculate the voltage that is applied in this circuit. So current is how much? 2 milliampere. This is 2 into 10 to the power minus 3. R total is 8. This is 4 ohm, right? R effective is 4 ohm. So this 4 ohm plus this 1 ohm. So 5. So this would be how much? 10 into 10 to the power minus 3. So this is the voltage which is the EMF that is supplied. Right. So and we also know that what is this EMF? This EMF is V L and V naught. So this is equal to 10 into 10 to the power minus 3. And P is given, which is 5 Tesla. L is 20 centimeter, which is 20 by 100 meter. And V naught we have to find out. So this thing we can calculate, right? So 1010 will cancel. And V naught would be how much? V naught would be 10 into 10 to the power minus 3. And we can write this as 2, and this is cancel. So 10 into 10 to the power minus 3 meter per second, right? Which is how much? 10 to the power minus 2 meter per second, or which is 1 centimeter per second. This would be the answer, right? So this is the answer. Is this thing clear, Tari? First, we calculate that what is the amount of voltage that we require for 2 milliampere current and for this effective resistance. That is the goal. Then we calculate this voltage, compare this with the EMF, right? Because this part is generating EMF, which is equal to PL. So is this thing clear to you, Tari? Is this thing clear? Yes, Tari, are you there? Hello, Tarif, can you hear me? Yes, Tarif, are you there? Hello, Tarif, can you hear me? Yes, Tarif, can you hear me? Tarif, are you there? Yes. Hello, Tarif. Hello, Tarif. Can hear. Hello, Tarif. Can you hear me? Yes, Tarif. Can you hear me? Yeah, please note down this part. Please note down. Why are you not
Yes,
replying? Yeah, please.
sir.
Yeah, did you understand this part?
Yes, sir.
Please note it down. Please, whenever you have noted it down, please tell me. Then we'll move on to this. Yeah, whenever you have noted it down, please. Yes, whenever you have noted, please. Yes, sorry. Whenever you have noted, please.
Yes, sir.
Yeah, okay, so now this was based on the length if we increase this, right, if we only move this part, right, then, then, then let us do the next question in which we rotate the coil, right? This part we not need that 21st question. Yeah, so then let us, okay, so the next question I will write it down, right? Because that is also important. and that is about rotations. What is the question that we have for this question? Circular coil of radius 8 centimeter and 20 turns is rotated, right? So if it is rotated about its vertical diameter with an angular speed of 50 radian per second in a uniform magnetic field, right? Horizontal magnetic field of B, which is 3 into 10 to the power minus 2 Tesla. The maximum EMF induced in the coil will be how much? Right, so this is the question. Now we know that we have this circular coil, right? And this is the horizontal magnetic field that we have. This coil is rotated diametrically, right? So this coil is rotated like this. So let's say, yeah, so let's say we have this coil, right? And this side we have this magnetic field, and this is rotated like this, right? So rotated like this. So as we know that for rotation, what is the EMF generated? What is the EMF generated for rotation? Can you tell me? And remember, there are n turns. So what is the EMF generated for rotation? Please go back to your notes and tell me what was the EMF. What was the EMF? What was the EMF for this rotation? Yes, Tarif, what was the EMF for rotation? Yes, Tarif, can you hear
Can
me?
you repeat?
Yeah,
Yes, sir.
what was the EMF for rotation? For rotation, what was the
For
EMF?
rotation.
Yeah, rotations. That part we did just a moment. BA omega.
Uh,
This was the
yes,
rotation. So BA
BLV.
omega. Yeah, no, BLEV is when we are just moving one arm. This is not
Okay.
rotation. We are moving only one arm, right? So then BLV is there.
Yes, sir.
But we are rotating this coil, right?
So BAV.
So then BA omega sine omega, right?
BA.
This is so EMF is BA omega sine omega t. But we have n turns of this coil, so that would be n. So this is the EMF, right? Now they are saying that EMF is maximum. So EMF is maximum, then what would be the sine omega t? Sine theta is maximum when? What is the maximum value of sine theta? Yes? What is the maximum value of sine theta? Sine theta maximum is how much? Yes, Tarif. Sine theta is maximum.
Yes.
Yeah, sine theta is maximum value of sine theta.
90.
90 is maximum, right? So at 90 degree
Yes,
that
sir.
is maximum. So what is the value? Value sine theta value.
90 will be 1.
1. So maximum value of sine theta is 1, right? So if we are calculating E max, then N, B, A, omega, these are constant. So this would be maximum. So this would be N, B, A, omega, right? So this is the maximum EMF. Now every value is given. N given, B given, and the area, this is circular, so area would be pi r square, right? So all the things are given. What are the things? A is pi r square. B is what? Omega is 50 radian per second. And B is how much? B is 3 into 10 to the power minus 2. And N is 20 turns. All these things are given. So pi r square would be how much? That would be 3.14. R is how much? R is 8 centimeter. So 8 by 100, 8 by. So these are the values, and we just put these values in here. So what would be that? 20, and B is 3 into 10 to the power minus 2. A is 3.14 into 8 into 8 by 100, and then omega is 50. These are the values which are given. So 50 za, 2, 10 za, 10, 10 za. So we have how much? This is 4 za, this is 5, and yeah. So let us keep this 10 there, because yeah, solving this part is so how much would be this thing? 3 into 3.14 into 8 into 8, and then this 10 and 10 to the power minus 2. So that would be 10 to the power minus that, right? So this would be how much? 8 8s are 64, and 3 4s are 12, 3 1s are 3, 4, 3 3s are 9.4 into 10 to the power minus 3. So what would be that? How much is this? Let us use the calculator. Yeah. 9.4 into 64, that is 602.88 into 10 to the power minus. So minus 3. So we can write this as 60.2 into 8 into 10 to the power minus 2. So nearly this is 60 into 10 to the power minus 2. Right. This is the maximum EMF. Is this thing clear, Tariq? Is this thing clear? If it is clear, please note down this part. Yes, Tariq. Yeah, what has happened to your internet? You are right. Hello, Tariq, can you hear me? Please note it down if it is clear. If you have any question, please ask. Yes, Tariq, please note it down. Yes, Tariq, are you there? Please respond.
Yes,
Yeah,
I can.
your internet
Yes.
is really fluctuating. So please note it down, and if you have any doubt in this question, please
Okay, sir.
whenever you have noted it down, please tell me. Yeah, whenever you want to scroll down, please.
So we use PA omega sine omega t when the
Yes, yes,
when so so we use the formula BA omega sine omega t
yes.
when the current
When the EMF is
is
maximum.
yes, so when the this one, right, when the current is going around the circular coil like full
Yeah, yeah. So that is the current is going in circular direction. Yes.
and when it's just circling around half of the coil we use BLV, right?
Yeah. So BLV we denote when we move this one arm, right? When we move this one arm, then we use BLV. This area, so we are changing the area. This is the whole frame, and we move this thing, right? So when we use BLV. So let's say we have this frame, right? We have this frame and we have this part. So this is attached. Now if we move this thing, right? So we are moving only this arm, right? So this arm will change. Let's say this was the area initially. This was the area initially. And if we increase this thing, so area is increased. This is the area now, right? So when we are moving one arm only, then we use this BLV. But let's say we have this whole aperture and we are rotating that aperture. So let's say we have this aperture, right? And we are rotating this thing. So we are rotating this thing, right? We are rotating this thing. So then we use BA sine omega t. Is that clear? Because what is the length of the Y in here that you are moving? You are moving the whole aperture, whole circle you are moving, right? You are not moving any one arm. Is it clear? This is the axis of rotation.
Yes, sir.
So is it clear? Whenever we are rotating, we use
Yes, sir,
this.
clear.
Yeah. So the idea. Okay. Yes. Whenever you have moved it down, please, Yeah, whenever you have noted it down, please.
Can you scroll down?
Yes, good. Whenever you have any question, please ask them, right?
Yes, sir. Certain.
Yeah. So the next question. One. Oh, this question, right? Why did we have this question? Question that we wrote that was already there. Right? So a circular conducting coil of radius is being heated by the change of magnetic field passing perpendicular to the plane which the coil is in. The resistance of this coil is 2 micro-ohm. The magnetic field is slowly switched off such that its magnitude changes in time as this. Right? So can you tell me that what is changing to create the EMF? Right? From Faraday's law, what is changing to create the EMF? Yes, what is changing in this question? Sorry, what is
Yes.
yes?
Correct.
You see that you have a coil,
Okay.
right? You have a coil, circular coil, and is being heated by the change of magnetic field passing perpendicular. So magnetic field is passing perpendicular to this, and the magnetic field is slowly switched off, and it is changing in this way, right? It is changing in this way. So what is changing? We have phi, which is BA, and these are perpendicular, so direction is 0 degree. So phi is only B. So in BA, what is changing and what is fixed? Is area changing? This area is changing. Area of the coil. Is it changing?
Yes, sir.
So this is fixed. This coil area is fixed. Only the
So,
magnetic field
yes, magnetic.
passing, yeah, only the magnetic field passing through it, that is changing. So you have some heating material, you are heating this thing, and due to heat of this thing, you are providing this magnetic. And this magnetic field is varying like this, right? T by 100 Tesla. So this is the magnetic field. This is function of time. So this is changing. This is not, right? So EMF generated, that is how much? That is minus d phi by dt. So we know that area is fixed. So this is only minus dB by dt. This is your EMF, right? And we know that the energy dissipated by the coil before the magnetic field is switched off, right? So the magnetic field is being switched off. So magnetic field is decreasing, right? The magnetic field is decreasing, and we have to find out the energy dissipated. So we have to find out the energy dissipated, right? Energy dissipated is how much? That is work done by this coil, and that is how much? That is V square by R T, right? VIT is the energy dissipated, right? And we know that I is V by R, so that would be V square by RT, right? This is the time, okay? So energy dissipated would be this thing. So what are the things that we have to calculate? E we know, R we know, and time we have to calculate. So time is when this energy is being zero. Magnetic field becomes zero, right? So that is the thing that we have to calculate. So first, let us calculate this EMF. EMF would be how much? EMF would be minus of A, and magnetic field is how much? That is 4 by pi 10 to the power minus 3, and 1 minus t by 100. So these are constant. So this will be outside area was how much? Area was coil conducting coil of radius 1 meter. So pi and r square, right? This is pi, and r square is 1 square. This is taken outside, right? And d by dt of 1 minus t by 100. So what would be the differentiation of this thing? Can you tell me? What would be the differentiation of this thing? What is the differentiation of 1 minus t by 100? Yes. So,
T by 100.
yes, what are you saying?
X minus log T.
Log t, where is this log coming from? Do we have any?
1 by we can take. No, that will be just 1 by T.
There is no 1 by t, right? There is no 1
Yes,
by
sir.
t. So, you see,
X minus something.
this is 1.
Yeah,
So,
X minus T square by 200.
okay, so let me write it simply. So, you have two terms, right?
Yes,
One
sir.
is 1. So, d1 by dt. The other way is d by dt of t by 100. So, 100 is constant, you take it outside. So, this is dt. So, d1 by dt, what is the differentiation of 1?
X.
One difference, constant differentiation.
Oh,
This
oh yes, 1.
so constant differentiation is 0.
Oh, yeah. Yes, sir, 0.
Differentiation of a constant thing that is 0. Right? What is the
Yes.
meaning of differentiation? Differentiation is that you want to check
Oh,
the
sir, I thought
difference.
integration, sir. Sorry.
No. Integration. Yeah. So, okay. Yeah. This is d by dt. Differentiation. So change in one with respect to time. One
Yes,
is constant, so there would be no change. So change would be
yes,
0. This is 0. And dt by dt is 1. So that would be simply minus 1 by 100. Right?
yes.
This would be minus 1 by 100. So this will cancel. So this
Sir,
would
were
be
we doing
4.
integration or differentiation?
We are calculating d by dt.
Oh, in differentiation. Sorry, sir.
d
I
by
get
dt.
confused with integration now.
No. Yeah. So integration, when I write it like this, integration of some dt.
Yes.
This is right. Yes. Okay, so this would be the EMF generated, right? This is the EMF. Now we have to figure out this time also. So time when the magnetic field becomes 0. So your magnetic field is this, and this is 4 into 10 to the power minus 3, 1 minus t by 100. This magnetic field is becoming 0. So that would be 4 into 10 to the power minus 3, 1 minus t by 100. So this A goes in the left hand side and this becomes 0. This is 1 minus t by 100. So you have 1 equals to t by 100. So time is 100 seconds. Right? Time you have calculated. E you have. R you also have, right? You have R which is 2 micrometer. So then you can calculate energy dissipated. That would be E square by R T. So E square is 4 into how much? 10 to the power minus 5, right? And 4 into 10 to the power minus 5. T is 100 second. And R is how much? R is micro, right? Micro. So this would be how much? This is 2, right? And this minus 6 goes above. So this would be 8 into 10 to the power minus 10 into this is 10 to the power minus so this goes 2 and 6, so that is 8. This is 8 into 10 to the power minus 2 joules. So this would be the energy, right? So this would be the energy. So we have any option like yeah. So they are writing in millijoules. So in millijoules, this would be how much? That would be 8 into 10 divided by 10 into 10 to the power minus. So this become 80 into 10 to the power minus 3 joules. So 80 millijoules. That is the energy. Right, did you understand this part? If you have understood, please note it
Yes,
down.
understood.
Yeah, please note it down. So this was a simple question, right? Please, this question had layers, but this was right. Please note it down, and whenever you want me to scroll down, please. Yeah, whenever you if you want me to scroll down, please.
But can you scroll down?
You have noted these